welcome to the next slide, ladies and gentlemen. We're going to try multiplying some complex numbers now. So the thing about complex numbers is that it works just like multiplying binomials with one key exception. And that's when we get I times I. And on a previous slide, we did look at that very briefly. If you get I squared as a result of any of your multiplication here, you're just going to want to remember that I itself is the square root of -1. So if I'm squaring a square root, I'm sort of like freeing that -1 from the radical or from the square root sign. So anytime I see I squared pop up in my answer, we're just going to do a strict replace with the number -1. Okay, let's try example 1 on page 25. We have 3i times the binomial, or it's not really a binomial because it's not a polynomial. So I'm just going to say two-term expression. So 3i times -5 plus 2i, and that's going to be 3i times -5. So that's -5 times 3 gives me 15, but it's negative. And the I comes along for the ride. 3i times 2i gives me 6i squared. And there's that I squared I said that was going to pop up. And we are going to replace that with the number -1. So I'm going to multiply by -1 here. So I get -6. And then just like we talked about on the last slide, we're going to reverse the order of that so that it has the real number first and then the imaginary number. So that's example 1, -6 minus 15i. On to number 2. We have 4 times -1, so that's -4. 4 times -2i gives me -8i. So I've multiplied that 4 times each expression in this second two-term. And then 3i times -1 makes -3i. And 3i times -2i is going to be -6. So in my head, I'm doing the coefficients first. So 3 times -2 gives me -6. And then I times I gives me I squared. Now we have two jobs. We're going to combine the imaginary terms, and we also have to replace this I squared. So I'm going to say -4, and -8 and -3 make -11i. And we have -6 times the -1 after that replace right here. And we get -4 plus 6 minus 11i. And notice that I kind of softly move that 6 over to the left because it's a real number. I'm going to combine these to get 2 minus 11i. And we're in standard form because the imaginary number is coming second. All right, that is 2 minus 11i. At any point, you can. Bye, Bannock. Have a good one. So number 3, let's just take a quick look at this first. You can see that these are very similar expressions. -6 plus I, -6 minus I. So this is not squaring because they're not identical expressions. But let's kind of check out and see if something weird might happen because of this structure. Hint, hint, something weird is going to happen. So -6 times -6 gives me positive 36. And then -6 times -I gives me a plus 6i. Moving over to the second part of that, I times -6 is going to be -6i. And I times -I gives us -I squared. So I'm going to start combining. I get 36. Well, there's no real numbers right now, but there are two imaginary numbers. And those are actually going to eliminate each other because -6i minus 6i gives you 0. So I'm going to write 36 plus 0, and then minus, change that to a -1. So this is saying 36 plus 1, and that is a real number of 37. So we're going to explore this on the next page as well when we do number 6. But I want you to try number 5 on your own, and that is 3 plus 4i squared. So just keep in mind we're going to have 3 plus 4i times another 3 plus 4i. And I'd like you to try that example on your own, and the answer will be on the next slide. Okay?